is created in R. I'll just give you an example with 4 values. Okay. Does anyone want me to repeat this? Okay. So let's go ahead. So as we can see, our model is not that great, right? It's not, it's 50-50, which is not a very good thing. So let's try with quadratic, okay? And it's basically similar line of code, okay? I will run the whole thing together, okay? And I will show you the result, okay? So let's see if it's any better or not, okay? So we see 43, 45 out of, again, very bad, right? So in fact, I have one more line of code here, which is called as confusion matrix. That is the function name. And it will do us the calculation of showing the confusion matrix. It will also show you the accuracy and certain other things, here. So first of all, as we can see, only 44% is correct, right? So very poor model that is being picked over here for this situation. Okay. Now the reasons may be many. Maybe the right kind of variables have not been chosen. Maybe the data itself is random, which is true because I had created this data set. So you might not get, that kind of promising results. So what we can do is I will use a real data set, okay, which is an inbuilt data set. You simply have to just copy this code here. I will send it to you again on WhatsApp.
Ma'am, for confusion matrix, is it a different library or is it a default library?
The base one, I think. I will just check. Is it?
Because
It's
it's
not.
giving, no, it's not working for me.
Okay, okay. Let me check. Let me just paste this first. And confusion. Yes, it is the CARET. That's the package. CARET, I think. Wait, let me just confirm. Yeah, CARET. Please load that package. Before loading, install it. CARET. Okay. Now try. So that's a very good function, confusion matrix function, which is because it will do all the things that you want to look for. The confusion matrix itself, the accuracy, what is the 95% confidence interval that you will have the correct result. So 37 to 51% chance that you will have the right result. Basically, that is what it is telling us. 54% no information rate. So 54%, we may not get the right answer there. Okay, and I think this is sufficient for you. Yeah, okay. Okay, now please run the new code that I gave you. Okay, I will run it all together. I have told you the steps. Basically, you load the data. This is the iris data set, which is already there within R. You don't have to load any additional Excel file. Train index is basically creating that data partition. This time it is 80-20. That is also allowed. Then train and test is basically loading that 80% and 20%. Okay, and then you apply the model. Okay. So I'll run it all at once. And now let's have a look at okay, before that, let us have a look at the data set itself. So I will show you the data. Head data. Okay. Now what is that I have called it? Train, let me call it train. Okay. Head of train. This is basically the length, the width, the petal length, the petal length, and the petal width, the sepal length and the sepal width of different species. Okay, of different species. Okay, so we have several species. We can only see Setosa here, but there are many of them. So in fact, there are 3 of them. Okay, and I will tell you the names. So these are the names. Okay. So please read and tell me in how many cases the model is good. In how many cases the model is good. I've highlighted the confusion matrix for you.
29 cases.
Out of how many in total are there?
Oh, 30 cases.
Out of 30, right? Which is a good thing, correct?
Yes.
29 out of 30, the model is giving you the right answer.
Yes. Almost perfect.
Yes, so if you can see here, the accuracy is 0.966, very close to 1, right? In fact, only one misclassification happened. Only one was wrong, and rest you can see 0, 0, which is what we would like. Ideally, it should be all zeros in the places you see here, right? But it was only one misclassification, which is okay. You know, no model is 100% correct. Okay. So this is a really good model fit for this particular data set. Okay. So that is what we understand. So if you use a real data set, definitely, you know, you can get something that is more meaningful. Okay. So is this clear?
Yes.
Okay. So what is the main purpose of discriminant analysis? To help you to understand what category, which group, okay, or how will you classify a particular new observation. And that is based on predefined groups. The groups have to be predefined, and any new data that you introduce then can fit into any one of the groups. Okay. So let me, yeah, I was here. So I have already told you about confusion matrix and so on. Okay, so how will you choose these independent variables? You know, you want really good variables, you know, with high discriminatory power. Okay, you don't want variables with low discriminatory power. Okay, so how do you choose this? First way, one way is you look at the data, you distribute, find out the histograms and the box plots and compare it. Visually, you can see, you know, if there is any different across the groups or not. So group wise, create the box plots, the histograms. That is one way in which you will understand that, yes, there is something different. So if you create a box plot for, you know, fraudulent and non-fraudulent, and you see that they both are same, okay, they are at the same level and they behave the same, then you don't have to include, you know, that particular variable into your analysis. But if you feel that there is a lot of difference, one block spot is up, another block spot is down, okay, for the same variable, then it is a signal that it's a very good variable to include in your analysis. The other thing you can do is look at the mean, median, standard deviation, see any differences are there over there. There are certain tests also which will help you to identify these variables. More commonly used, you can do the correlation analysis. Pick one independent variable, compare or find out its correlation with the output variable, okay, in the dependent variable. So if you have strong correlation, that means it's good, okay. You can do a stepwise selection. Say, for example, you can begin with one variable as you are doing in your presentation in the factor analysis. So you started with 20, 30 variables, you removed some of them, you tried, maybe now you had 15 variables, still it was not working. You removed one by one, you removed some until you got some, you know, 10 to 12 variables which were really, you know, significant for your factor analysis. So that is called stepwise selection. Okay. So either you start with the full group and you go on removing one after the other, or you start with one and you keep on adding to it. Okay. So that is called stepwise selection. So that way also you can select the independent variables among all the variables that you have. Okay. Then besides this, your own knowledge, you know, maybe you are an expert in that area. So you know that, you know, this is a variable which is going to highly affect my output or my grouping. So you can include them. Okay. So that is also one way. Okay. And cross validation, as I said, you know, you divide the data, you split the data. That is also a very good way to identify whether our variables are having that power or not. So as we saw the coefficient, we can compare them. Okay. So if the coefficient is very less, so it's having least effect. If it is high, it's having high effect. So that way also you can identify which of independent variables are having that discriminatory power to be included in the model or not. Is that clear? Now, in both my examples, I used all the variables except for the SI, serial number or the ID. Okay, but you can reduce it. It's not necessary that you use everything. Is this point clear, everyone?
Yes.
Yes. What
But
about
can we use the factor analysis and then use the discriminatory analysis? So we put all the variables in factors and then we use this one. No
yeah,
problem.
no problem. Yes. So that way you have lesser number, right? So you
Yeah.
can. But mainly what I said, you see the correlation between the factor and the output variable, then it is even better. So you know that factor is important or not. Sometimes the whole factor itself may not be important, right? Could be. So among themselves, they are correlated. You understand, in factor analysis, among themselves, they are highly correlated. But are they correlated with the output? That is something you have to check. Whether it's a factor or it's a variable. Okay. Okay, so some of the questions, I just explain the confusion matrix. You can expect such questions. So I will give you the confusion matrix and you can say whether this is model is a good one or not, right? Are you all confident you can do that?
Yes, I hope so.
Okay, very simple. Just look at, which are the right answers, find the total divided by the all the, numbers there. So you know how accurate the model is. Okay. Or if I give you the coefficients, you should be able to tell which is having the weakest effect, which is having the strongest effect. Okay. So these are, the important questions that you can expect from here. And besides this, application, where will you use discriminant analysis? What is the purpose of it? How is it different from cluster analysis? How it is different from when will you use it as compared to multiple regression? So these are the other important questions. I hope by the end of this session, you are able to answer all of these. Any of these questions that I mentioned you're not clear about, please let me know. Yes, anyone? Is everything clear here? Just going
Yes. All good.
good. Okay, let me ask you a question. What are the two types of discriminant analysis?
Linear and
Linear and
quadratic.
quadratic.
Yes, very good. When will you use, when do you prefer to use quadratic? When is quadratic preferred than linear?
So is it dependent on the correlation between the
Covariance.
covariance between the factors and the variables?
Covariance between different groups are same, you can use linear. If the covariance between different groups are not same, go for quadratic. Okay. So you understand the difference, right? So if you have fraudulent activities, yes, okay, then the variance you find for that group should be same as the fraudulent activity, no. So if both variances are same, okay, to say in a very simple words, if both the variances are same for both the groups, you go for linear, otherwise go for quadratic, okay. Another question is, I told you already about the confusion matrix. What is the purpose of cross validation? Cross validation, data validation. What is the purpose? Why do we divide the data into two parts? Training, testing. That's called cross validation.
To check the accuracy and how the model operates.
Yes, how the model is performing, right, on a new data set. Okay, so you should be able to explain the procedure. We divide the data into, different ratios like 67, 60, 40, 70, 30, or 80, 20. Okay, we perform the analysis on the training set, we check the model on the testing set. So basically this you should be able to explain. Okay, and this holds for any model. It's not just restricted to discriminatory. Okay, and especially this we talked about here because in discriminatory you require large samples. If you don't have large samples, you have to do this. Okay, that is one of the assumptions which is different from rest of the analysis methods we learned so far. Okay, so you should have large samples here. Okay, another question let me ask you. If you have 100 observations in your data set, in order to have a successful discriminatory model, how many observations should be there in each group, considering there are 4 groups in your data? I'll repeat the question. Suppose you have 100 observations in your sample, 100 records in your sample. In order to successfully apply discriminatory analysis for the data having 4 groups, how many records should be there in each group in your data set?
25. So
Correct.
they should be equal.
They should be equal. That is one of the assumptions, right? For the discriminatory analysis, you should have equal number in each group. I said there are 4 groups and totally there are 100 observations, so each 25. Clear? Yes, what about the rest? Did you get an idea how this calculation has been done? Let me know with a thumbs up. Or should I explain? By the way, tell me, should I explain this?
Maybe we can go through it again. Yeah.
Okay. Okay. Again, let me tell this. What basically I asked you, I have 100 observations. I have 100 rows of data. Okay. Now, one of the assumptions of discriminatory analysis is that how many ever groups you have. Say, for example, in our previous example of R, we saw there are 3 groupings. The first example we saw in R, there were 2 groups. Yes, no group, right? So if in our data set we have 4 groups, I said, okay, maybe the 4 groups are active customer, moderately active customer, passive customer, moderately passive customer. So these are the 4 groups you have in the data set. I have 100 observations. I have 4 groups. Ideally, to apply discriminatory analysis in a good way, in the right way, in order to get the good results, how many observations out of the 100 should be there in each group? So how many passive customers I should have? How many moderately passive customers should I have? How many active customers should I have data on? How many moderately active customers I should have data on? That is the question. So what is the answer? You divide whatever number you have 100 observations, you divide it by the number of groups. So in this case, 100 divided by 4, which is 25. I'll ask you another question now. Similar situation, you have 100 observations, but 2 groups. So how many observations should be there in each of the groups?
50-50.
Right? 50 each. Okay. So basically these are the questions you can expect. Okay. Nothing too much technical. Okay. I hope this is fine. Still, if things are not clear, please let me know. That's it for today. I think I have recorded the attendance. Yeah, I have. All right. Yeah. If there's anything else, let me know. Mostly next week, we should have class face to face. So we will have the presentation first and then we will have our regular session. Okay. And meanwhile, if you have any questions, please let me know. All right. That's it. Thank you so much, everyone.
Thank you, Doctor.
Thank you, Raz.